Welcome to yet another episode of Shortcast over Coffee. Today, my guest is Professor Sachidanand Tripathi. Dr. Tripathi is an acclaimed Indian scientist in atmospheric sciences. He's a professor at IIT Kanpur and has won India's top science award, the Shanti Swarup Bhatnagar Prize, for his work. Dr. Tripathi is an elected fellow of the country's major science academies and holds the prestigious J.C. Bose Fellowship. His research focuses on Earth's atmosphere, oceans, and climate. In this episode, we discuss the recent news about the air quality in Delhi, findings of his research in this field, and the measures that are being taken to improve the air quality in India. Let's now get right into it. Professor Tripathi, thank you so much for joining the podcast.
Thank you. Thank you for having me here.
Yeah, just to give the audience some context, Professor Tripathi graciously had agreed to record this on a Friday evening at 8 p.m. So truly shows his professionalism and passion for the subject. I see that you went to MNNIT Allahabad for your master's in environmental engineering, and this is a time, I think, early 90s, right? What was the scenario back then? Was there so much hype about climate change and the environment back in those days?
I would say that there was no hype as such, but during my undergraduate in IIT BHU, then IT BHU, we had a subject basically I believe, in 8th semester on environmental engineering. And we had a professor from chemical engineering who taught that. And I still remember it was a book, I think, by PV on environmental engineering, which had some maybe couple of pages on aerosols, particulate matter. And that fascinated me. I still remember very little at that time in 1992 when I was in final year, my undergraduate. That very little thing about aerosols somewhat got me hooked into that. And then we also had a professor of hydraulics. He's no more, late Professor V. Mishra. And he was a champion of environment. In fact, he went to Rio and he got some of the top awards of that time because he was really, truly, fighting for environment that time. And that what somewhat kind of fascinated me. And that time I felt that I should kind of pursue environmental engineering rather than other more followed disciplines of civil engineering, be it structural engineering, geotech engineering, or hydraulics, to say like that.
Was there something specific about aerosols that interested you, something that you could connect with the place you were living in, or was it just the pure chemistry aspect or the civil engineering aspect of it?
No, I think it was more environment and air pollution at that time. That what I mean, I knew as much about aerosol as you see the size of those tiny particles, if you can scale it to the knowledge. But I think I was kind of fascinated about air pollution, although it was not at all talked about subject in India.
So you moved to MNNIT Allahabad, you finish your master's, you go to University of Reading. They call Reading as Reading in the US. I don't know how it's pronounced in the UK, by the way. Is it Reading?
It's called Reading, not
Reading.
Reading, yeah.
Reading, yeah. So you complete your PhD and then you start your career. I also noticed that you went to Goddard Space Station in NASA and you had a bit of a stint there. Just curious, what was an environmental scientist doing in Goddard Space Center? Tell me about your experience at NASA.
Well, so while doing my postdoc at Oxford University, I developed some interest in doing, aerosol modeling in planetary atmosphere. And I did pursue that subject for some time, right? Because aerosol being my core area of expertise. So I have developed a couple of models to predict the charging on aerosol particles and how their size will evolve in, of course, in Earth's atmosphere as well as planetary atmosphere. And that led me to land up at Goddard because I did some modeling of aerosol microphysics in atmosphere of Mars and Titan. And that is what was pursued at Goddard that time.
Okay, that's quite interesting. So you have done a lot of stints abroad, and you have been working with your team at IIT Kanpur for many, many years. One of the most prominent work that you have done over the years is Taj Mahal Discoloration, and it's been heavily talked about in social science textbooks, and I remember reading about it in 7th or 8th grade while I was in school. Your work has actually led to major policy interventions in Agra city. So tell me more about that.
Yeah, so just to tell you that how it all started, that back in 2009, I was invited to participate in a flagship program of India-US. It's called Frontier of Science. And I was invited as a lead speaker. I still remember the name of that session was Haze, Atmospheric Haze. And it's a very unique program. I don't know whether it's continued or not, where 6 or 8 disciplines will be chosen across science and engineering. And in the audience, you will have everyone sitting and listening about very diversified, areas about different leading speakers. And end of the meeting, actually, they used to basically the program was administered by IUSSTF in India. And they that time announced that, well, we'll also give a kind of a very small seed grant to make the collaboration, the people who have come together from India and US to sustain that and take that work forward. And we had some friends from US, they came and then we said we should do something interesting. And it just happened to me. I said, well, we should try to do something about Taj Mahal because we don't know why. And that time the meeting happened in actually Agra. It was, such a coincidence. And everyone went to see Taj Mahal. And I think that time cleaning of outer surfaces of Taj Mahal was going on. And I said, we should try to understand why we need to do this regular cleaning of the outer surfaces of Taj Mahal. So that is how it just all started. And then we designed some sampling. We did measurements. We then developed a model on that. And that model could really tell that what kind of material or particulate matter in this case, and what type of particulate matter actually is causing discoloration of Taj Mahal, based on modeling, which was, of course, very much substantiated based on the measurement as well. As a follow-up, then, we could also link the 2 primary sources, which were responsible for emissions of these particulate matter, and then, of course, subsequent to depositing on the outer surfaces of Taj Mahal marble, which was causing discoloration. Then, actually, after the paper was published, then Standing Committee of Lok Sabha, which is the lower house of Indian Parliament, the Committee on Science and Environment took cognizance of that. I believe that the whole committee made a visit to Agra sometime in 2015. And post to that, then they made some instruction, and then a couple of other measures followed, including stopping of, biomass burning, flying of vehicle within 5-kilometer area. So many such measures were taken just to stop further deposition and discoloration of the surface.
And did you make any more research on what happened to the discoloration after these measures were taken, and did you see signs of significant improvement?
What we know that those frequent cleaning, what they do with a very peculiar kind of mud, I do not know that whether that frequency has decreased. My feeling is that yes, somewhat it has not been seen, because otherwise you see very kind of routinely those scaffoldings were created and then cleaning is happening, which is very elaborate because structure is massive. So I would imagine that yes, in some way there is some reduction, but we have not followed it up on that.
Yeah, I mean, it must have been such a huge satisfaction seeing your research bring about such a big policy intervention and change. So congrats on that. I want you to break down the kind of reasons for bad air quality in India. So, I mean, air pollution is a major threat in India, causing apparently an estimated 1.7 million premature deaths. And deaths due to outdoor air pollution are rising. But what is the kind of air pollution in India? So, I mean, with my limited knowledge, I know that there is particulate matter, there is air pollution due to biomass burning, there is air pollution due to construction. Like I'm based out of California, so California sees a lot of air pollution due to forest fires. So, what are sort of the major kinds of air pollution in India?
So you see, generally there could be many kind of pollutants, and which mixture of that we generally refer to as air pollution, which could cause adverse effect on human health, other living species, ecosystem, or buildings, etc. But we tend to monitor globally all the countries which monitor it to protect their environment, and in this case, ambient environment are two kind of particulate matter, which is 2.5 and 10, which is based on their sizes, and then a couple of pollutant gaseous pollutants, which are carbon monoxide, ozone, nitrogen oxides, sulfur dioxide, and some of the volatile organic compounds. And sometimes they also monitor, but they are not part of regulatory monitoring, policies, which are metals. Now, in India, if I have to say one thing, which is singularly responsible for most of the adverse effect, it would be particulate matter. And because of the health-related concern, it would further come down to particulate matter 2.5. Now, particulate matter 2.5, when you say, you are only looking at the total mass, or actually it's a mass concentration, that how much mass do you weigh in unit volume of air, which has size less than 2.5 micron, okay? And 1 micron is 1,000th of millimeter. So they are very tiny particles, but they are not all of same size. So you will have basically sizes ranging from probably a few nanometer, which is 1 millionth of, millimeter, or 1/10 to 9th, right? 1 billionth of a meter. Starting from that to about 2.5 micron, you would have a whole distribution. And the complexity does not stop there. Rather, you also have different size of particles will have different chemical composition. And both of these would depend on where they are coming from, what sources are actually emitting them. So sources and its location would partly only determine that what would be the size and its chemistry of PM 2.5, what we are seeing in the atmosphere. In addition to, there is a lot happen within the atmosphere. The atmosphere itself acts like a chemical reactor. So that is where the complexity comes. And being country with a very large population, a very diverse set of economic activities, growing economy, definitely the whole set of economic activities or range of economic activities leads to many different operations, processes, which would of course lead to emissions of these particles, and of course its precursors. So, and that is where this whole thing makes it very challenging to understand.
Professor, we talk a lot about the major contributing factors of pollution, but you are a researcher, you are a scientist. Help us break down how you conduct your research. How do you take samples? How do you build models? We don't have to get too technical about this, but maybe briefly explain how you conduct your research.
So we basically do three, mainly three kind of investigations. We have a very well-established laboratory at IIT Kanpur. It's called National Aerosol Facility. It's one of its kind in the country, where we actually look at, different aspects of particulate matter or aerosols. We try to measure their sizes. We can measure their chemistry in the laboratory. Okay. We also have built a mobile platform where many of these instruments can be put on this, laboratory, which can go on wheel. So basically, it's ready to sample wherever it go, and we can do almost all the measurements what we do in laboratory in the field. And as of now, as I speak to you, we are doing those measurements in the capital of state of Uttar Pradesh, where actually we live in. And so the basically advantage of such kind of laboratory is that we are able to measure both size and chemistry of these tiny particles anywhere where we go, and in a very short time, using some kind of models, we can provide what sources are actually contributing to it in a very short time. And we call it real-time source apportionment. Because if you know sources in a rather quicker way and in a reasonably precise way, then this information is very helpful for policymakers or regulators because they can go after them. Third research, what we are also doing now is that we are trying to expand the reach of monitoring. And we are doing so by developing sensors in our laboratory. And these sensors are very tiny, measuring devices. So we have helped many startups to integrate these units, which are very, very small. It's like size of your iPhone, reasonable size iPhone. They are autonomous in the sense that they have their own network, they have own their memory card, and they can run through solar, and they very precisely, I would say reasonably precisely, they are calibrated well. They measure PM 2.5 and can also measure some of these gases, and they transmit the data in real time. So, and the best part of it is that they are much, much cheaper than other regulatory grade instruments. So basically, in the price or cost of one regulatory grade instruments, we can deploy around 50 such sensors. So as we actually discuss now, we have been putting about 1,400 sensors in these two largest states of India, which are Uttar Pradesh and Bihar, by putting one sensor in every block of these two states. And a block actually consists of several villages. So Uttar Pradesh has about 850 blocks and Bihar has about 550 blocks. We have already completed this deployment of network in Bihar, and then we are on the way to do this deployment in Uttar Pradesh. And this kind of data help us to understand the urban and rural divide in terms of air quality. It can also give us, using many kind of data analytical techniques, using machine learning and AI, that how do we form airshed, where are the hot spots, why they are forming, many such things. And most importantly, it can help us to create exposure map at a very high spatial resolution. So these are the things we are doing as far as measurement goes, or source determination happens, or increasing the overall extent of monitoring. And then another group of postdocs who work with me are trying to estimate the social cost of air pollution. Or in other words, how can you monetize the health-related adverse impacts using some kind of models.
Okay. Wow, lots to unpack. Lots of research going on, and I don't think we as commoners know the level of research that is being conducted at IIT Kanpur. And you mentioned about bringing the cost of sensors down, and I think that is extremely fantastic. Low cost, low form factor sensors is helping immensely. And I did read an article or two about how many of these are being employed in the state of Uttar Pradesh and Bihar, and as you rightly pointed out. Uh, Dr. Tripathi, you mentioned about the air quality in villages versus highly populated cities, right? And I have been, reading a lot of articles about the reason for bad air quality in cities like Mumbai and Delhi. And one of the common findings is that it is the satellite cities, or it is the cities that are in the outskirts of these metropolises that are causing the air quality to go down because of various reasons. Uh, has that been your finding as well? Uh, do you think satellite cities are impacting the air quality in much bigger cities?
See, although I should also tell you that there is a national level program which is called National Clean Air Program in India, and which has tried to expand the overall footprint of monitoring in the country. So in the last probably 5 years, we have the government monitors, which are the expensive ones, and regulatory grade have increased from about, I would say, 200 to about 350 in the last 5 years, because program was launched in 2019. But the fact that being such a large country, we have about 4,000 towns and cities, right? So, and the program is focused on 133 cities, and many of them still do not have a single monitor. And that is where this need arose that we should have this sensor-based monitoring going on so that we can understand what's happening in different cities and towns. So I would not jump to that conclusion that the satellite cities are mainly driving the air quality of the main city around which they are developing. But I would add that one thing is very clear, that what we understand, that there are a couple of factors which are definitely driving haze in city of Delhi. Okay, one of them being the biomass burning related emissions. So biomass burning related emissions actually consist of primary particles and also biomass combustion generated gases. And we have seen that there is a preferential growth of these nanoparticles, nano primary particles, because of condensation of these organic gases on that, which are primary gases coming straight from combustion. And then once they cross a certain threshold of 100 nanometer or so, then other kind of gases are inorganic mainly, and then they drive their growth. So this part we know, and we also know that yes, biomass burning is a more widespread process. It happens within the city, and it has a very strong seasonal pattern. And it also certainly must be going around in the satellite cities. But it's, I think, difficult to say unless we have more measurements to really pinpoint that satellite cities are driving the air quality of larger cities. We need some more information.
Hmm. Yeah, seems like we don't have enough data to conclusively say that is how it is. Uh, you touched upon the fact that biomass burning is one of the major causes of haze in the city of Delhi, and we speak about it every year, end of October, early November. This is a very common topic of discussion. And talking about the city, I mean, the state of Punjab, Punjab has known to be growing highly water intensive crops. Again, this is a sidetrack, not completely pertaining to air quality. But the state of Punjab has typically grown highly water intensive crops, and there is a scare of drought if this persists. Is it important to encourage crop diversification? And my question to you is that will crop diversification also decrease the amount of biomass being burnt and hence improve the air quality in some way?
Yeah, definitely. People have looked into that. Primarily to arrest the slide in the groundwater level in Punjab, or maybe presumed, slide, which was probably happening pre 2011. Then they brought a new legislation, and which somewhat prohibit farmers to sow kharif crop, which is the rice crop, before 1st of July. And this actually pushed the entire kharif cycle into the middle of October, and that certainly has some kind of cascading effect on the crop harvesting, followed by the need for the rapid cleaning of the field, and therefore burning the stubble in the field, and compounded with the adverse meteorology over the whole region, certainly it somewhat contributes to haze. Having said that, I totally agree that crop diversification is required, not only from the point of view of saving the environment. I'm quite confident that it would also save water. It would help farmer also in sustaining their profession, their livelihood, and I think climate-wise also it would be a prudent choice.
Yeah, it's been in discussion for a long time, and I think it's high time that we do encourage crop diversification. Um, the other thing that I wanted to touch upon was that there has been actually a progress in stubble burning, or there has been a decrease in stubble burning over the years. But we still have haze in the city of Delhi, and I think the last week there has been significant discussion about it. Uh, do you think this year specifically, the reason was a compounding effect of stubble burning plus some other climatic factors like maybe wind is what caused it to be this bad this year?
I think so. That what data we looked at, it showed that there is about 50% reduction in overall number of fire counts in Punjab and Haryana for the month of October and November compared to 2022 for same months for the two states. So definitely there is some reduction in fire counts, and I assume that there would be corresponding reduction in the emissions of gases and particulate matter as well. And it is also true that this year we have seen post 26th October, there is a remarkable change in the atmospheric mixing height. So, and the winds in the lowest column of the atmosphere, which actually the two factors, the boundary layer thickness and the columnar wind profile, these two, if you combine, actually gives you the overall dispersing power of the atmosphere, that how quickly that pollutants can go up and then they will, redistribute, has been remarkably less. In fact, it is probably 1/4 or 1/5 compared to what you would have seen in late September or the October, something like that. And it is strongly linked with the extreme pollution episodes. So definitely, I think meteorology has played a big role this time. Not to say that, yes, farm fire are also probably contributing as well as the local emissions, but that meteorology has been very, very adverse. What I see, definitely that's the case.
Yeah, and regarding implementation of measures to curb the stubble burning and to improve overall air quality, there has been a multi-decade effort in a place like California, which sees a lot of wildfires. What have been some of the things that places like California have gotten right? I know it's a big issue in California, but what have been some of the things that are probably some things that the administration can learn from California?
I think California has been a success story. In fact, I believe that since they established California Resource Board, there has been a study that it showed that the growth of California in terms of per capita income and the drop in particulate matter. And it showed that there was a factor of 3 growth and a factor of 3 drop from 1970 to 2010. And that shows the overall progress which car in unison with Environment Protection Agency, they could bring into California. And definitely several such steps have been taken in India. I told you that about National Clean Air Program, which has put emphasis on all three important pillars of air quality monitoring on the whole, right? Bringing more monitoring, putting more efforts into resources, human resources, making sure that we have solid science, also bringing steps towards mitigation and awareness. So basically working at all facets of air quality management as such. Then we have a commission for air quality management in Delhi, NCR, and adjacent geography, which is kind of been brought in, recognizing the fact that you have an airshed which is there over Delhi and city, and that needs to be managed. So several such steps are taken. I think we need to invest more into monitoring. We need to have this understanding that the challenge is year-round, and we need to have effective air quality management which should work around the clock. We also need to invest more into human resource training and development. We need more people. Like you are from California, that CARB has about a staff of 2,000 people on its own, just for the state of California, which consists of, I think, 1/3 of scientists, 1/3 engineer, 1/3 legal professionals. So this is where I think we need to invest more. And that is true for Delhi NCR, and it is true for across the country.
I was actually looking at some of the pictures of the city of LA from the 1970s, and it looked no different from what we see in Delhi. Lots of haze, people wearing gas masks and whatnot. And the positive fact is that it is reversible. It when the right measures are taken, it is completely reversible, and it can bring the quality of air up, as many cities have proved around the world. Dr. Tripathi, you mentioned about these sensors and monitoring systems, right? And I noticed that the IITs work very closely with the government in the National Clean Air Program. So the data that you collect, who are the major customers of this data, and what do they do with the data that you collect from these sensors that you have employed?
So for the two states I mentioned before, that which we are putting large network in UP and Bihar. So in both states, our partners are the government agencies. So in Bihar, we have partnered, and we are working closely with the State Pollution Control Board, Department of Environment, and Department of Rural Development in Bihar, and the equivalent or their counterparts in the state of Uttar Pradesh. And so this, as far as these networks go. In addition, for example, we put a major network in Lucknow city, independent of this large network some time back, and where we work with the city corporation. And earlier we had been running some network of modest size in city of Jaipur, Guwahati, Chennai, twin city of Chennai and Kanyakumari. And in case of Jaipur, we had a memorandum of understanding with Pollution Control Board of Rajasthan. So generally, we work either with Pollution Control Board or other government agencies or the city council offices, so that either there is a data sharing with them in real time, or analytics which comes out from the data, it's made available to them so that they can act on it.
Okay, that's fantastic. There were some cloud seeding trials over the city of Kanpur, which have been part of a success story. Do you recommend something like that to improve air quality, or uh, is it something worth trying in the city of Delhi?
See, we have a well-established aerospace engineering department at IIT Kanpur. We also have a flight laboratory. And just to tell you, because you have done some research about me, so you would have known that I have done experiment with aircraft back in 2008 and 2009, more to understand aerosol properties, which has direct consequences to climate. So we have used ISRO aircraft that time, and now we have our own aircraft at IIT Kanpur, and which is equipped with cloud seeding, apparatus. And then 2 trials were made at Kanpur, and they had success. So if you see sometime that the situation like what we are currently witnessing over Delhi, where just because of this stagnant conditions, the haze is simply not dissipating at all. That these kind of situations sometimes require some intervention. Now, some interventions were earlier suggested, they were tried, but in these situations, they have not given expected result. My feeling is that cloud seeding generally has been used to, kind of accelerate cloud processes to bring rain in drought-prone situations. But there are also inferences or instances which have been cited that people have used it for elevating pollution-like situation. And I think it is worth trying over Delhi if it can, somewhat bring some relief.
Yeah. Well, Dr. Tripathi, excellent points, and I'm so glad that your team at IIT Kanpur is working so tirelessly and has brought about so many different changes, and your research is clearly seeing an impact. Before we end this podcast, I want to ask you, every single year around this time of the year, we talk about haze and pollution and whatnot. Are you frustrated that every single year there are news media outlets reaching out to me? I saw your piece with NDTV, and a few other media outlets. Are you just frustrated and tired of speaking about this? What are your thoughts? Like if you were let's say the CM of Uttar Pradesh or the CM of Delhi, how would you do things differently?
No, I think I'm not at all frustrated. We have made progresses. We have made progress in terms of monitoring. As you have noticed that many IITs are working, we have a network which has been, built by bringing people from NITs, IITs, National Laboratory, who are working with the cities in implementation of clean air program. And but definitely we know it's as you have noticed that LA people have seen this situation in 1970s, and even I think this year or last year when they had some forest fire, this situation is still recur.
Yeah, in the
We had
northeast
fire.
of the US, I think there was forest fire in Canada, and that completely impacted the northeastern cities in the US. Yeah.
It impacted in New York, and I think some of the this smoke I think went even deeper into United States. So countries like United States who have so much of already established kind of infrastructure, manpower, and agencies to deal with this problem also sometimes find helpless. So I think we are very much committed, and I think over a period of time, definitely we'll be able to solve this problem. But it is certainly is going to be a little bit time and more effort is required. I must add that.
Yeah. And I'm also hearing reports that there is a lot of manpower and resources allocated from the central level. And in some instances, it is the lack of cooperation between the state government and the central government that is the gap between implementing these projects versus seeing good results. So once that is sorted out, I think we are going to see extremely good improvement in measures being taken. So very, very positive, and I absolutely love your positivity. I mean, though you agree to the fact that it may be a slow process, but at the same time, you are not at all frustrated, and you are taking the step in the right direction, which is absolutely great to see. So thank you. Thank you so much, Dr. Tripathi, for spending time on a Friday evening, even after work. I think, like I mentioned earlier in the episode, it just shows your passion for this topic. So thank you so much.
Thank you. Have a good day. Thank you for reaching out to me. Thank you so much.